Jai Hind one and all, welcome back. Now today we are going to learn about transformation in acceleration component. Previously we have learned about how a displacement component can be converted into a velocity component. Now we know that my u dash is equal to u x minus v. Now we have to convert this into a acceleration component. So how we can do it? As we understand with our previous knowledge that velocity component or acceleration component is nothing but dv by dt. Okay. So if you talk about how we can convert that velocity component into an acceleration component, then simply what we have to do is we have to differentiate our velocity component with respect to time. So how we can do it? Okay, so again we have a velocity component as ux dash is equal to ux minus v. Now here v is a constant. Now if we differentiate with respect to time, what we will get is d ux by dt is equal to d ux by dt minus dv by dt. Now as you understand that v being a constant, it can be nullified and we can say that value of it is 0. So what we are left with du x dash is equal to du x dash, and we can write, as we understand that du by dx is nothing but acceleration, so we can write it clearly that my this component is become ax dash and my this component is become ax, so I can clearly write it as ax dash is equal to ax. Now, so this is my complete vector. So this shows, as you can see, that this shows that in all inertial reference frame our body will be observed to have a same acceleration. As we understand from our previous knowledge that inertial frame is one which has non-accelerated motion. So from here we can prove that all the inertial frames are of inertial frame. Now, why Galilean transformation has failed? Why Galilean transformation has failed? So according to the Galilean transformation, the law of mechanics are invariant. That means they cannot change. But under Galilean transformation, we have observed that the fundamental equations of electricity and magnetism have very different forms. So this is one of the reasons for failure of the Galilean transformation. Again, if we measure the speed of a light along x direction in the frame f, then in the frame f dash the value becomes c dash is equal to c minus v. How it is changing? We know that speed of light cannot change and its value is 3 into 10 to the power 8 meter per second. But as we observe from here, you can see that we have understand that my ux dash is nothing but ux minus v. If we replace our ux dash and ux by c x dash and c, then will come out to be c x dash is equal to c minus v, which is not possible because we know from our previous knowledge that speed of light is nothing but 3 into 10 to the power 8 meter per second. So here we observe that in Galilean transformation our speed of light is also changing with time, so which is not possible. Okay. So next. So this is after Galilean transformation, what next? And that is Michelson Morley experiment. We also call it experiment. So these are the objective of Michelson Morley experiment was to detect the existence of a stationary medium ether. He proposed that all the things in the world is moving around a constant stationary object or a medium, and he called it ether. As you understand from here also, stationary frame of reference, that is ether frame. So they proposed a frame of reference and they called it ether. Now, which was assumed to be required for the propagation of a light in the space. So they understand that, and they assume that the ether is a reference frame. It is a hypothetical frame in which they assume that for the propagation of light we require that frame. Now, in order to detect the change in the velocity of light due to relative motion between Earth and hypothetical medium, which I call ether, is Michelson Morley perform an experiment. And what is that experiment? So from here you can understand what they have here is. Okay, now what they have, they assume a source of light. They have taken a source of light, anything, a sun, a lamp or anything. This experiment was performed in a dark room. Now, they used a source of light from where light rays are coming out. Now, because they are scattering over here and there, for that purpose they have used one lens over here. They use a lens over here. And what is that lens? That is a concave or a convex. This is a convex lens because we need converging lens. This is a converging lens. And we all know what is converging lens, right? So I don't understand. So this is a converging lens. And what it did? Multiple rays came from a source and they aligned them in a row, parallel rays. They align them in a parallel rays. This is the main motive of the convex lens. So a source of light, a rays of light coming from that, then it focused on a converging lens, and that converging lens is taking them and making them a parallel rays of light by converging them. Now what happened? So rays coming, we have taken only one ray. And now we have used a semi-silvered glass plate. A semi-silvered glass plate. Semi-silver means if you talk about a mirror has a polished one face and other is a reflecting plate. But in a semi-silvered, the painted part is partially painted and partially unpainted. So why we have done is so that the two phenomena of ray of light can be used over here, and these are refraction of light, and another is reflection of light. So this semi-silvered glass plate will perform two things and two work, and that is they will reflect and they will reflect. So I'll take one by one. So one mirror is here and one mirror is here. We are not talking about this area part. We are just focusing upon this source, this mirror and this B point. So currently we are focusing upon A and B mirror. We are not focusing about A dash and B dash mirror. So when a ray of light coming from a lens focused on a semi-silver glass plate, what will happen? It will reflect and move towards a mirror, and second one will get refract and it will move to mirror 2. So two things has happened over here. The source of light came, focused on a semi-silver glass plate, and then one get reflected and one get refracted. So what will happen? It will go like this. After reflection, because it's a 90 degree, it will come back to this point. And again, here also you can see they will go like this, and after reflection, they will come back by a 90 degree. And when they meet over here, they will go along simultaneously. They will go simultaneously. They will go simultaneously in a telescope. They will go simultaneously in a telescope. So what they have assumed? What they have assumed is when and this distance is assumed to be L, and if this distance is assumed to be L, then this distance is also assumed to be L. So both the mirrors, this mirror and this mirror at the same place. So what will happen? After reflection or after refraction, they will come back. They assume that they have to come back at this point simultaneously, and after interference or after combined with each other, they will move down to telescope. And the big question is it possible? And the answer is very big no. Why? Because that frame, that experiment has been performed on the Earth, and Earth is moving constantly. So what will happen? So while that ray moved there and coming back, that whole apparatus moved to this place, and this apparatus from here, from B, it moves to this place. So this is not possible. Okay. So you can see from here, the light from a monochromatic source S falls on the semi-silver glass plate G inclined at an angle 45 to the B. Why it is at 45? So that it can reflect and refract simultaneously. Now, it is divided into two parts by the semi-silver glass. One ray will get towards M1 and another will go to M2, and these two rays fall normally on mirror M1 and M2, normally means 90 degree, and are reflected back along their original path and meet at point G. Enter in telescope. So what I have told you is same written over here. Now, by doing a simple derivation, we will understand how this thing has happened. So for this, what we have to assume? We have to assume let the mirror M1 and M2 are at equal distance, as I have told you that they are at same distance L from the glass plate, and further let C and D be the velocity of light and the apparatus on the Earth respectively. So on the Earth, the speed of light is C, and for the apparatus on Earth, it is, for the speed of light we have taken C, and for the apparatus on the Earth we have taken V. So it is clear from the figure that the reflected ray, one from glass plate G, strike the mirror M1 at A dash and not at A. So what they have said? They said, what I have said, we assume that it strike over here, but actually it strike over here. So we have assumed that it might have strike on A, but actually it has strike over here. Likewise, it has come from this point, but it is not coming from this point. This is coming from this point. So this is the assumption over here we have taken. Now we will take two things. We will take this complete triangle. We will take this complete triangle G A dash G, and in this, if you clearly see, this G A dash D is nothing but a right angle triangle. We'll apply a Pythagoras theorem over here. This distance is CT, this distance is VT, this is L, so we can understand and we can find out what we are getting. Now, you can see from here. Okay. So, in triangle GA dash G, we have taken a right angle triangle and we call it GA dash square is equal to A dash square plus A dash D square, where GD and A dash are equal. So, if we apply GA dash, what is GA dash? What is GA dash? GA dash. G A dash is nothing but a speed of light. It is nothing, sorry, this is nothing but a speed of light with time. So this is a distance. This is a distance. So it covers a distance of G A dash. And what is that? Light is going, speed of light c in a time t. So this is speed into time, and that is a distance. So G A dash is nothing but a distance. Now again, I will talk about A dash. What is A dash? This distance GD and A dash is the same. So my apparatus is moving like this. And what is the speed of my apparatus? That is same of Earth, and that is v. So it is moving v in the same time. It will move v into t. And if you talk about AD dash D, this is L. So this is also L. So you will get this value. So you will get this value. Sorry. Okay. So you will get this value. So what we will get is Ct square is equal to Vt square plus L square. So what we will do is we will rearrange it, and then we'll find the value of t from it. So how we will do it? So this is my C. I am opting it. V square is equal to L square. Okay. From here you can clearly take p square out, and this come out to be p square c square minus v square is equal to L square. Take this down and you will get as p square is nothing but equal to L square upon c square minus v square. So if we underroot it, what we will get is, we will get p is equal to under root of L square is nothing but L, and down we will get c square minus u square under root. So this is your final value of time t. This is the value of time t. You can see from here also. You can see. So hence the time taken, time elapsed will be equal to L upon under root of c square minus v square. So now, if t1 be the time taken by a ray to travel the whole path Ga dash, okay, give me just 1 minute. So he assumed that t1 is the time to elapse this and t is the time for this. So what will get? So t1 be the time taken by a ray to travel the whole path Ga dash g. Then how much time he has taken? What we have understand from the derivation, that we have got the value of Ga dash by t. We got the value of Ga dash d, but for the whole path, this and this, so half path, it is t is equal to L upon under root of c square minus v square. But what about the whole path? That is the twice of it, and that we can say that t1 is nothing but twice of t. I hope you understand this. Okay. Take the value. Okay, fine. Okay, fine. So from here you can understand this. I'll explain you everything. Now, so my T1 is equal to twice of T. And what is my T? My T was under root of L upon under root of c square minus v square. So we can put the value over here, and what we'll get is 2y of L upon, and we can write it as c square minus v square r. We can write it as like this. And now just this is a fundamental rule that always take your c out and you will get the answer. So we'll take c as out. So c square upon half is c. So we can write that 2l upon c. So what we are left with? We are left with c square is out, 1 minus v square upon c square. Take this up, take this up, and what you will get is this is my T1 and this is my 2L upon C. If I take it up, then it will become 1 minus V square upon C square, and it is plus, so it will get 1 by 2. And by applying a binomial theorem, what we can do is we can actually make a formula over here. So what is that? By applying binomial theorem, that power part will come here with its sign. So this is minus, 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 plus, and this half will come inside. So what you will get is, you will get P1 is equal to 2L upon C, and 1 minus is plus V square upon 2C square. So this is my final value. So this is my final value. You can see from here. This is my T1 upon 2L upon C is equal into 1 plus V square upon twice of C square. This is my final value of what? This is my final value of moving from here to here. Now, what is next? Next is we are moving this way also. My frame is moving this way also. So what is that? How we can get this value? So now in case of transmitted ray 2 means that this one which is moving longitudinally towards mirror 2, it has a velocity c minus v to apparatus when it is moving from G to B and return degree, because we have seen that the speed of light is always optimal. That means it is c minus v. That means it is getting subtracted from v. So moving part is c minus v, while we are moving like this, it is c minus v. But when it is moving, if my this way is plus, then this way is minus. So this way will be c minus of v, and this is nothing but c plus v. Okay, you understand that? So it has a velocity c minus v related to the apparatus when it is moving from G to B, and during its return journey, its velocity, its relative to apparatus is c plus v. If t2 be the total time taken longitudinally means from here to here and here to here, then we can say my t2 is nothing but the distance will remain the same. So I'll say my distance is L upon c minus v plus, and the returning part will be c plus v. Okay, cross multiply, you can do it. Okay, keep L outside, and this part will be c plus v plus c minus v. I am taking the whole part and down. A minus b into a plus b is nothing but a square minus v square. So we can write it as c square minus v square. Right. So from here we'll cut v to v, and we're left with t2 is nothing but equal to 2y of LC upon c square minus v square. Okay. What next we can do is take this c down, and we'll get the value of it. Okay, and the same process we have used over here. How? See, we'll use this, take this c square down, minus v square by c. Take c out. Take c out. If you take c out, what you will get is T2 is nothing but 2L upon C 1 minus v square c square. So the same pattern has come, but with a difference, and that difference is here power is 1 and their power is half. So again we'll take it up. 2L upon c 1 minus v square upon c square minus 1. So you are left with 2L upon c. Take binomial theorem again, and you are left with 1 plus v square by c square. And this is the same value as written over here. This is the same value as written over here, and this is your value. K2 is equal to 2L upon c 1 plus v square upon c square. What is the difference between the two values? And that is here you have 2 and here you don't have 2. Here we have 1. So this is the basic difference between these two values. And now what you will say, what is the path difference? And path difference can come out to be delta t, and that delta t is nothing but t2 minus t1. So again, this is my t2, this is my t1, all the values are same. 2L by c will come out, 2L 1 plus v square upon c square minus 2L upon c 1 plus v square by c square, and my final value after solving all things will come out to be L v square upon c cube. So this is my final value over here. So this is my final value. So again will come on Einstein's special theory of relativity, STR. What Einstein has said. So this is Einstein gave his special theory of relativity on the basis of experiment. So Einstein uses the Michelson Morley experiment for explaining its theory of relativity. So Einstein's first postulate of the theory of relativity is all the laws of physics are same or have the same form in all the inertial frame. So in the inertial frame, all the laws are same, as we understand. In all inertial frame of reference moving with uniform velocity with respect to each other. And this postulate is called law of equivalence. It means that all the laws on the earth with reference to inertial frame moving with uniform velocity are same. Now, Einstein's second postulate of relativity is the speed of light is constant in free space or in vacuum in all the inertial frame. We understand that. We always know that in free space the speed of light is 3 into 10 to the power 8 meter per second. So, and this is called law of constant consistency. Okay. So this is for the relativistic mechanics. Thank you so much.